Hi guys, we're going to talk today about lesson 832, which is factors and integral roots. And you guys already know what factors are. Factors are when you put something in parentheses and it's x plus 2 or x minus 3. Integral roots just means the easy roots that have integers. So we're going to look at the graphing calculator and see where the graph crosses the x-axis at some easy places to help get this process going. Now I'm going to warn you, this is not a short process. This is a long process, especially the first time we go through it. It's going to take some time. So bear with me, bear with yourself, take some good notes. If you have to watch this video a couple times, it's okay. We're given this equation. We're only going to do one example today. We're given this equation, this polynomial function, x to the fourth minus x cubed minus 5x squared plus 3x plus 6. And we have two jobs today. And our first job is to factor this completely. And our second job is to find all roots in exact form. All roots, this is a fourth degree. So I'm expecting to find 4 roots. Exact form just means I don't want to round it all. So if I get the square root of 7, I'm just going to leave it as square root of 7. My first step in this process is to use the graphing calculator and table to find the integral roots. Remember, roots is the same thing as zeros, solutions, or x-intercepts. Integral, remember, just means integer. We're just finding the easy ones. If you don't have a graphing calculator at home, go to Desmos.com. It's free. It's easy. Type this equation in. You're going to be able to see the same thing, maybe even better than what you're going to see on your own graphing calculator. Okay? So all I did in y equals was to type this in. I look at the graph, and you guys should not be at all surprised to find the shape is a W. Remember, with x to the fourth, it should be a W. Down is 1, up is 2, down is 3, up is 4. It might also be an M, but this is a positive orientation, so it's going to be a W. Okay? And when I look at the calculator, I can visually see it cross the x-axis. That means it has real roots. If I didn't see it cross the x-axis at all, or maybe this part of the W was somehow floating above, okay, so if it looks something like this, then there might be some non-real solutions. I'm expecting to see 4 real solutions here. I can also see that they're at about -2, -1, and +2. And to verify, I'm going to go to the table. And remember, when I'm looking for zeros on a table, I'm looking for when y is equal to 0. So when I look, I see y is 0 when x is equal to -1 and when x is equal to +2. And to be honest, I don't even know which one of those it is. I'm going to call that one 2. So I have used my graphing calculator and the table to find the easy roots. Okay? Step 2 is to take those roots and to write them as factors. Now remember, when I take roots or solutions and write them as factors, it just means I'm going to switch the signs. So instead of writing -1, I'm going to write x plus 1. And instead of writing 2, I'm going to write x minus 2. Now there's something here that we just don't know yet. Our job is to find what this is, to multiply with these two to get back to our original polynomial. Okay? And our next step, step number 3, is we're going to use polynomial division to help us find this last factor. So really what I'm doing is I'm taking the original, x to the fourth minus x cubed minus 5x squared plus 3x plus 6, and I am dividing it by one of my factors, and it doesn't matter which one. I'm going to pick x plus 1. You could have done x minus 2, and I'm using polynomial division here. So I'm putting x plus 1. I don't know how long this is going to be. Just as a reminder, whatever goes inside this box has to add up to that. So I'm going to put x to the fourth right inside the box. Check. I'm going to undo or find the division. I'm going to multiply through. And remember, I need it to be -x cubed, but it's positive. So I need to subtract in order for these two terms to add up to what I'm supposed to have. Up top, I get -2x squared. Just multiplying through. I'm supposed to have -5. So I need to subtract 3x squared, not cubed. Okay. I'm going to divide, multiply. Okay. I'm supposed to have positive 3x, but I have a -3x, so I better add 6x. I get 6, 6. I'm supposed to have 6. That means my remainder is 0. And remember, I better have a remainder of 0, otherwise I made a mistake somewhere and I have to go back. Now, when I divided by x plus 1, I had x to the 4th divided by an x. I get x cubed, but I know x minus 2 is another factor. So I'm going to go ahead and I'm going to divide by x minus 2. But when I do this, I'm not going to go back and divide by the original. What I'm going to divide by is what I got here. I'm taking this part and dividing by my other factor, x minus 2. Okay? So what I get inside here better be equal to what's inside the black bubble. So I have x cubed, x squared, negative 2x squared. Ooh, I was supposed to have negative 2x squared. And for some students, this becomes confusing. I'm going to put a placeholder of 0 just so I don't make a mistake. I'm going to make sure I go to each degree on the way down. So of course this top would be 0. I'm going to put 0x just as a placeholder. Okay, but I'm supposed to have negative 3x. So those add together to make my negative 3x. So I have x cubed. I have negative 2x squared. I have negative 3x. I get a negative 3 up top. I get a positive 6 here. I'm supposed to get 6. I have 6. So my remainder again is 0. And again, it should be 0. If the remainder is not 0, this is not a factor of this in the black bubble or the original, and we've made a mistake and we have to go back and fix it. Okay? So now, step 4 is I'm going to use all of this work. All the hard part is done. I promise you, all the hard part is done. Okay? And I'm going to write in factored form. This was one of my jobs originally. Well, I already knew x plus 1, and I already knew x minus 2. So what's my last factor? It's whatever I get at the end of the polynomial division. It's x squared minus 3. Okay? So this is the original polynomial in factored form. Now, my very last step, like I said, the hard part's over, guys. The very last step is I'm going to use the zero product property in my factored form to find all the roots in exact form. Remember, it's x to the 4th, so I'm not done until I find 4 solutions. When I use the zero product property, I just put in a 0 instead of y, and I'm solving this equation that's already factored out. You did the hard part, okay? Remember, all we're saying is if I set this equal to 0, what would x equal? Well, that's negative 1. You probably don't even need to show work for this. Same for this one. What does this give me? It gives me an x equals 2. We even knew that at the very, 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 very beginning when we graphed the equations, okay? But we weren't done until we get x to the 4th. That's why we had to go through all that other work, okay? This last step hopefully is not difficult. We put 0 equals x squared minus 3. This is a step where sometimes you're going to have to do the quadratic formula if there's an x squared and an x. In this case, I don't have that, so I'm going to simply undo by adding the 3 to both sides. Then I'm going to take the square root, and remember that when there's an x squared, I expect 2 answers, so I need to put plus or minus square root of 3. And again, it asked for exact form, so I don't want to find plus or minus 1.732 approximately. I want to leave it in exact form. Okay, so we've answered our question. We have factored, and we have found all of the roots in exact form. If you need to, go back and watch the video again. If you need to, sign up for a Google Meet with me.